Includes rain and snow, but also sleet, which is basically partly frozen rain, and hail, those solid, hard balls of ice that can sometimes drop down during really severe storms. So, how do they measure it? When you hear a news anchor say an area got 30 millimeters of rain, where does that very specific number come from? It comes from an instrument called a rain gauge. It's wonderfully simple but highly effective. Rainwater just falls into a funnel at the top and collects in a measuring cylinder down below. There's a scale attached to the side that lets us measure the exact depth of the gathered water. So, 30 millimeters in the gauge literally translates to a 30 millimeter depth of rainfall across that entire area. Let's move on to element number 3, atmospheric pressure. This is literally the weight of the air pressing down on us. You've probably felt this yourself if you've ever traveled up into the mountains. As you gain altitude, the air physically becomes thinner. Because there's just less air stacked above you, the atmospheric pressure drops. Lower pressure means there is less oxygen available in every single breath you take. Your lungs and heart have to work so much harder to supply your blood with oxygen, and that is exactly why people often feel dizzy, tired, or breathless at high elevations. To put this into perspective, normal atmospheric pressure right at sea level is usually around 10-13 millibars. We measure that using a tool called a barometer. But now, consider Army personnel stationed at Karting Law in Ladakh, sitting at a staggering 5,600 meters above sea level. The pressure up there, it's only about 650 millibars. At those extreme lows, taking the time to pause your journey and let your body properly acclimatize isn't just a friendly recommendation, it is an absolute requirement for survival. Now, talking about pressure leads us perfectly right into our fourth element, wind. Wind is, very simply, the movement of air, and it is entirely driven by pressure. Air just naturally wants to rush from areas of high pressure to areas of lower pressure. Understanding wind speed and direction is absolutely crucial. Airline pilots need it for safe takeoffs and landings, sailors rely on it to navigate the oceans, and farmers watch wind direction closely to predict incoming storms and figure out how quickly their fields might dry out. To properly measure wind, meteorologists use two distinct instruments. First is the wind vane. You've probably seen these on top of old barns or rooftops. It has a pointing